In this video, we'll do a quick introduction to integration and look to see how we can integrate a polynomial function. So integration is to do with our calculus. Remember, in the previous set of videos, we explored differentiation, which was all to do with finding the gradient or how finding the rate of change of something. Now, integration is closely related to differentiation. It's just the other way around. It's a bit like going from a differential and working out what the original would be. So, for example, if I said dy over dx, a gradient function was, I don't know, let's say 3x squared, um, we could work backwards and figure out what the original y looked like. So that's one use of integration. Another use is to do, again, with the curve itself. So if we had some curve, do you remember if we took the tangent at a single point, that gave us the gradient? Well, rather than having the gradient function, integration allows us to, let's take 2 points on the x-axis. What we could do if we integrate, we can actually use our integration to work out the area underneath the curve. Okay, from a maths point of view, that's quite interesting, but from an engineering and physics point of view, this allows us to work out things that change as time changes or as distance changes, for example. And we'll see that in an upcoming video. But let's have a little look a bit more closely at some of these ideas. So I've already mentioned here that if we had some curve y, if I wanted to find the area under the curve, I have to do something called integration. So if I wanted to find that area, this is linked to integrating. Now, the notation for integration is kind of similar but different from our differentiation notation. Do you remember if we were differentiating, if we differentiated y, we would have dy over dx. Well, if we integrate, we use slightly different notation. So if I wanted to integrate y with respect to x, this is the notation I use. So this sort of elongated s, if you like, is our integral, or the symbol for integration. So this tells me that I want to integrate the function y with respect to the variable x. So remember here, this said we wanted to differentiate y with respect to x. Here, we want to integrate y with respect to x. And when we do that, that gives us a function, and that allows us to work out the area under the curve, or maybe what an original function might have looked like. All right, so let's look at the basics again. We'll come back to that when we look at some examples. But let's look at how we integrate a polynomial. Remember, we looked at how to differentiate polynomials before. So now we want to integrate polynomials. So what were the two rules for differentiation? So if we want to differentiate a polynomial, you know, something that looks like y is equal to a x to the n, do you remember what we did? We had two steps. We reduced the power by 1. And then we multiplied by the old power. So the power would have gone down to ax to the n minus 1, and then we multiply by the old power, so we would have had an x to the n minus 1. Now, integration is the exact opposite. So if we want to integrate, we want to do the opposite. So let's think about the opposite of these two rules. So rather than reduce the power by 1, we increase the power by 1. And instead of multiplying by the old power, let's flip everything around. We divide by the new power. Okay, so as an example, let's say we had y is equal to, um, well, let's do what I just mentioned. Yeah, let's do this. So 3x squared. Okay, so if I wanted to integrate y with respect to x, I would take that term and I would increase the power by 1, so 3x cubed, but I need to divide by the new power, so I need to divide by 3. Right, well, 3 divided by 3, they cancel out, just gives us 1, so we're left with 1x cubed, or x cubed. Okay, now the new thing that we need to do is, in general, when we integrate, we have to add a constant of integration. So we have to have this plus c. Okay, and let's do another example. So let's look at y is equal to 4x to the 5 take away 3x cubed. Okay. Um, all right, let's have a go at this one. So if I wanted to integrate y with respect to x, let's follow our rules here. So we increase the power by 1, so 4x to the 6, divide by the new power, so it's divide by 6. Let's do the same thing with the next term. 3x to the 4 divided by the new power, so divided by 4. But remember, we've got this minus sign, so we still have that minus, and then we add our constant of integration, that plus c. All right, let's tidy this up. This becomes 2/3 x to the 6 minus 3/4 x to the 4 plus c. Okay, so again, very brief introduction to how we integrate a polynomial. Now, just like before, we don't have to stick with y's and x's. They could be, you know, velocities and times, accelerations and times, forces and distances. Okay, so all of these letters could mean, all the variables, the y's and x's, could actually have different names.